Today we're going to go over Chapter 21, Inference as Design. If we use the results of a significance test to make a decision, then we either reject the null hypothesis in favor of the alternative hypothesis, or we fail to reject the null hypothesis. We hope that our decision will be correct, but it is possible that we make the wrong decision. There are two ways to make a wrong decision. We can reject the null hypothesis when, in fact, it is true. We call this type 1 error. And we can fail to reject the null hypothesis when in fact it's false. And we call this type 2 error. So we're going to go through and discuss how you would find type 1 and type 2 error. So it's best if you actually make this table and put it within context, but this is the generic table. And so when the null hypothesis is true, we would have this column, and when the null hypothesis is false, when we reject the null hypothesis, and when we fail to reject the null hypothesis. And so when we reject the null hypothesis and it's true, it's a type 1 error. If we reject the null hypothesis and the null hypothesis is false, we made the correct decision. When the null hypothesis is true and we fail to reject the null hypothesis, it's a correct decision. But when the null hypothesis is false and we fail to reject the null hypothesis, we have a type 2 error. And it's best if you put this within context using this table when you're doing problems like this. We are interested in knowing the probability of making a type 1 error and the probability of making a type 2 error. A type 1 error occurs if we reject the null hypothesis when in fact it is true. When do we reject the null hypothesis? When we assume that it is true and find that the statistic of interest falls inside the rejection region. The probability that the statistic falls in the rejection region is the area of the shaded region, or alpha. And like I said, alpha is the significance level. So here on a one-sided test, this is alpha. And that's also your rejection region. And in the center, we have P. Therefore, the probability of a type 1 error is equal to the significance level, alpha, of a fixed level test. The probability that the test will reject the null hypothesis when, in fact, the null hypothesis is true is alpha. A type 2 error occurs when we fail to reject the null hypothesis when, in fact, it is false. We do not retain or fail to reject the null hypothesis when we assume that it is true and find the statistic of interest falls outside the rejection region. However, the probability that the statistic falls outside the rejection region is not the area of the unshaded region. Think about it. If the null hypothesis is in fact false, then the picture is not correct. It is off-center. So we'll show this in a two-sided test. This is your rejection region. And here we have our rejection region as well. This is a two-sided test, so you need to remember that this is alpha over 2. Okay, this is P, our null, in the middle. And then what happens is we're going to go straight down with our notes. To calculate the probability of a type 2 error, we must find the probability that the statistic falls outside the rejection region, the unshaded area, given that the mean is some other specified value. So we're going to look at that in the next picture here. And this is still with your two-sided test. And notice that they line up on your notes. And this is the upper end of your rejection region, or excuse me, sorry. This right here is the upper end of your rejection region, and this is the lower end if you were to draw lines straight down. Our P is now moved over here. This region here is known as beta. And then this is 1 minus beta. And that's the power of the test. And this is now your rejection region. The probability of a type 2 error tells us the probability of failing to reject the null hypothesis when it is actually false. The complement of this would be the probability of not retaining, in other words, rejecting the null hypothesis when it is actually false. To calculate the probability of rejecting the null hypothesis when it is actually false, you compute 1 minus the probability of type 2 error. This is called the power of the significance test.